Welcome to today's video. Today we're focusing on solving systems of inequalities, both algebraically and we're also going to focus a little bit on graphically. And we're going to show this mastery in class by scoring at least an 80% on the exit ticket. Now, hopefully you have the note sheet in front of you. If you don't, make sure you take out a separate sheet of paper and you can write this down and we can give you a fresh note sheet tomorrow. Now, the big thing we want to focus on is finding solutions to inequalities and finding non-solutions. If we look at this first one, we're given a graph. We're not given the inequalities. Yes, we can create them, but we're not worried about creating them. I just want to know each ordered pair as a solution or a non-solution. So what we're going to do is we're going to go through, you want to plot the points on the graph and see where they fall. If I start with -4, +1, well, if I go over -4 and I go +1, that's in my shaded area, so that's a solution. +5, -3, well, +5 and I go -3, okay, that's also in my shaded area. If I look at 0, -6, well, that's on the it's the y-intercept of my solid line. Because it is on my solid line, 0, -6 is a solution. A solid line means it is included. It can be equal to. So that is a solution. Now, -8, -2. Well, that puts us all the way out here. That's not in my shaded region. So it is not a solution. 0, +4. Well, that's my y-intercept of my dashed line. A dashed line means it's not included, so 0, -4 is not a solution because it's on the dashed line. It is not included. -6, +1. -6, +1. This is our intersection point. However, because there is a dashed line, and a dashed line is part of the intersection, it is not a solution. +7, +2, well, that's in my shaded area, so that is a solution. And the last one, -7, 0. Well, that's not in a shaded area, so that is not a solution. The big thing for determining solutions from a graph is you have to see, does it fall in the shaded area where the graphs intersect? And if it falls on a line, is it a shaded line or a dashed line? Dashed lines, they are not included. Shaded lines, solid lines, excuse me, they are included. Now, the other way we're going to talk about solutions is algebraically. And algebraically just means we're doing algebra. So we want to circle all the ordered pairs that are solutions to the system of inequalities. In order for it to be a solution, it must work for both inequalities. It must work for both. If it only works for one, it's not a solution. If it doesn't work for either of them, it's not a solution. So if we look at the first one, I have x is 4 and y is 6. Well, if I use my first equation, I have 6 is greater than -4 times 4 minus 8. Well, if I use algebra, -4 times 4 is -16 minus 8. 6 is greater than -24. Well, is that a true statement? Yes, it is a true statement, so now we can check our second equation. I have 6 as my y again, is less than or equal to 2 times 4, my x value, minus 2. I'm going to use algebra. 2 times 4 gives me 8. Well, the question is 6 less than or equal to 6? Well, 6 is equal to 6, so yes, this works. This point, and I'm going to highlight it, this is a solution to the inequalities. So now, let's check the second one. Again, I have x and y. I'm going to use my same equation, so this time it's going to say 4 is greater than -4 times -3 minus 8. Well, that means 4 is greater than +12 minus 8. Is 4 greater than 4? Well, no. 4 is actually equal to 4, so this is not a solution. If we look at our third inequality, or third set of points, we have x and y, so -8 is greater than -4 times 0 minus 8. Well, if I use algebra, I have negative 8 is greater than 0 minus 8. Well, negative 8 is greater than negative 8. Is that true? Well, no, negative 8 is equal to negative 8, so that is not a solution. In this case, the only solution that we have on here is that first set of points. Now, there are other solutions, but we're just focusing on those points. If we look at example 2, again, we want to know all that are solutions. So we're going to plot some points. If I go positive 4, positive 3, positive 4, positive 3 does not fall in the shaded area. So no, it is not a solution. If I go negative 6, positive 5, well, that falls in my shaded area. So that is a solution. 0, positive 3. That's my y-intercept, but because it's on a dashed line, it is not a solution. Negative 2, negative 7. This falls on my solid line. Since it is a solid line, it is a solution. 4, negative 4. This is our intersection point. Because one of them is a dashed line, it is not a solution. 0, negative 6 is my intercept of my solid line. So again, because it's on that solid line, it's included, so it is a solution. Make sure you always look at your lines. If it's a solid line, we know that's greater than or equal to or less than or equal to. Well, that equal to tells us it's included, so we can do that. If it's just greater than, it cannot be equal to, so it's not included. Now, example 3, again, we're going back to the algebraic. We want to know, are these points solutions? In this case, the equations are given to us in standard form. We don't have to turn them into slope-intercept form because we still have x's and y's, so use what's there. Ooh, and I'm still in the highlighter. So I have x and I have y. I'm going to plug it in. 2 times 0 minus, 2 times 0 minus 7 times 6 is greater than or equal to negative 42. Well, 2 times 0 is 0. 7 times 6 is 42. 0 minus 42 is negative 42. So we need to know, is negative 42 greater than or equal to negative 42? Well, yeah, they're equal to each other. So that works. So now we need to check our second equation. We're still using the same x and y values, so 6 times 0 plus 7 times 6 is greater than negative 14. Well, 6 times 0 is still 0. 7 times 6 is 42. 0 plus 42 is 42. And you have to ask yourself, is 42 greater than negative 14? Well, yes, it is. So this point is a solution. Now, because of room, I am going to have to, unfortunately, erase it. Or I'll write to the side. Just make sure you know this is for the second point. We're going to use x and y again. So 2 times 7 minus 7 times negative 8 is greater than or equal to negative 42. Well, 2 times 7 gives me 14. Negative and a negative make a positive 56 is greater than or equal to negative 42. Well, this gives me 70, and you need to decide, is 70 greater than or equal to negative 42? Well, yes, it is, so that works. So now we need to check our second equation. Same x and y's, but now 6 times negative 7 plus 7 times 4 is greater than negative 14. This gives me negative 42 plus 28. Well, negative 42 plus 28 is negative 14. You need to decide, is negative 14 greater than negative 14? Well, no, they're equal to each other. So since that answer is no, this is not a solution. Now, for the third point, and I'm going to scroll down some. My third point is negative 7, 4, and my equations we're still using So now let's plug them in. Well, if I start with my first equation, I have 2 times negative 7 minus 7 times 4 is greater than or equal to negative 42. Well, 2 times negative 7 is negative 14 minus 28 is greater than or equal to negative 42. This gives me negative 42. So we need to decide, is negative 42 greater than or equal to negative 42? Well, yeah, they're equal to. So that works. So now check your second equation. 6 times negative 7 plus 7 times 4 is greater than negative 14. Well, this gives me negative 42 plus 28 is greater than negative 14. I'm left with negative 14 is greater than negative 14. Well, is negative 14 greater than negative 14? No, they're equal to each other. So because they're equal to each other and one of them did not work, this is not a solution either. So in this case, the only solution given to us is that very first one. But you cannot stop once you find a solution. Inequalities can have multiple answers, unlike equations where there's only one set answer. Now, if we look at example 4, we want to know all the ordered pairs that are solutions to the inequalities. Well, 0, negative 2 falls on my solid line, so that works. Negative 1, positive 4. Well, it's a point on my dashed line, and it's not in the shaded area, so no, it does not. 1, negative 5. Well, that falls in my shaded area, so that definitely works. If we do 6, 2, we go positive 6, positive 2. Because it's on the solid line, that is a solution. Make sure you really pay attention to whether it is a solid line or a dashed line, because that does change whether your answer is a solution or not if it falls on the line. Hopefully you filled out these notes. Bring any questions you have and your note sheet to class tomorrow. I look forward to seeing you then.